Good afternoon, everyone. Thank you for joining us today for Solar for Starters course, which is the first module in the series, The Solar Revolution, Dawn of a New Era. My name is Kayla Gerstenberg, and I have the pleasure of being the moderator for today's course presented by GBRI. Let's discuss the course description for today. With the booming solar industry in mind, our newest course, Solar for Starters, will address the important and the fundamental factors of the solar industry, along with analyzing the practical aspects, the promises and the challenges of the solar industry, all in one. The course will describe what is solar, why it's important, how it works, and where the industry is headed. This course creates the basis for a more detailed look at GBRI's new solar series, The Solar Revolution, Rise of the New Era. This series will feature modules for homeowners, investors, designers, installers, as well as project managers and sales professionals. I'd like to introduce today's instructor, Jeffrey Matthews. Jeff holds a bachelor's degree in electrical engineering from the University of Houston. As a solar engineer and trainer, he's been involved in solar PV training and consulting projects. Jeff has hands-on project experience in designing as well as implementing solar projects for residential and commercial entities, both domestically as well as internationally. He plays a very active role in solar advocacy groups in San Antonio and Austin, Texas, while participating in monthly solar contract meetings in cities around the state to stay current with the ever-changing and dynamic solar industry. He's conducted training workshops at the University of Houston for over 8 years, training students in general and industry-specific skills related to solar. At GBRI, his passion for teaching and sustainability come together, providing a platform to promote sustainable practices to ensure a brighter and more sustainable future.
Of course, it all begins with the sun. The sun is a source of light and thus the source of life. It is mostly a gaseous body, of course, composed mostly of hydrogen, with some helium and traces of heavy elements. The gases swirl and flow under the influence of gravity, magnetic fields, and heat energy. But how is this energy produced? Through nuclear fusion. The sun is a main sequence star, which means it generates its energy by nuclear fusion of hydrogen nuclei, which are the lighter nucleus, nuclei in this case, to produce helium. And this production of helium produces a huge amount of energy. To be exact, the sun fuses 620 million metric tons of hydrogen each second. Of course, EM waves cover a whole range of electromagnetic radiation. The radiation we are most familiar with is the visible spectrum, as you can see here in green. That is also the UV spectrum and the near infrared spectrum. So, how solar? How do we implement these systems? So, now that I've talked about what the panels are, the different types of panels, the different types of inverters, how they come together on a roof, on a residential roof, let us look at where the industry is going. Where are we headed in the solar industry? But first off, let's look at where we are. Let's look at it through some case studies. This is a project that I was part of. It was a residential project here in San Antonio. The process was something like this. They look at our energy bill, we look at the energy bill, and as you can see here, the current CPS bill is in gray. What we try to determine is how much of this bill do we want to offset. There's a certain line that we draw. And we drew the line at 500. If you see 500 on the left side, we decided that we would install a system that produces 5 kW. And so anything under that will be provided by the system for those months. Anything above that would have to be consumed from CPS. And everything below 500 would be produced by us. And thus you can see the future CPS bill with solar. So when you put the solar on there, the bills reduce dramatically because you're chopping off 500 of it. And sometimes you're even producing more energy than you can consume. So what happens to that? It goes back to the grid. Probably your neighbor gets it, or the neighbor's neighbor, whoever's using energy right beside you. The path of shortest resistance. So moving on. So these were some numbers that we crunched. If we were to install a 5 kW system, with a certain multiplier, you would know that you would be producing about 600 kilowatt hours. In a year, you would be producing about 7,200 kilowatt hours. And then we look at how much is the house actually consuming. It's 11,700 kilowatt hours. So we're offsetting 7,000 of it. So from solar, we're expecting to meet 61% of the energy needs, while CPS would meet the rest 39%. So just to re-emphasize, you know, clean energy is winning when the solar industry grew 10 times faster than the economy in 2013. So I wonder why we don't embrace it completely. I mean, I don't wonder why, but I wish they did. Lobbying is really strong, you know.